Hello my dear students. So now we are going to continue the lesson where we try to understand the physical properties of matter in relation to its particulate nature. So in the first two chapters, you all got a good understanding about what particulate nature or discontinuous nature of matter is. What is it? All matter, irrespective of their physical state, that is solid, liquid or gases, they are all made up of particles. Those are the constituent particles, and between those constituent particles there is space. So that is what we call as particulate nature or discontinuous nature of matter. So now we are going to relate the physical properties of matter to their particulate nature. So under that we need to discuss the solids, liquid and gaseous state. Think of some examples in your day-to-day life. If we take an ice cube, that is also made up of water particles, but it is in the solid state. So from the fridge, from the refrigerator, if you take the ice cubes and you place it in the, put it into a container, you place it outside for some time, you all know it will melt and become water. So there it is the liquid state of water. Again, you all know if we boil water, water becomes steam. That is the gaseous state of water. So, in all these instances, there are the water particles because now you all know everything is made up of particles. In ice, the water particles are arranged in a certain manner. That is why the ice cubes have a certain shape, certain volume, they have certain properties. Whereas water, it's arranged in a different manner. So, water has its own properties. And when it becomes steam, there again the arrangement becomes different. So, that is what is shown here. So, we will try to understand this first, students. If you take ice, a cube of ice, like in the first diagram, you all can see the particles are very closely arranged and they are arranged in an organized manner. Whereas if you take liquid, the same thing when it comes to liquid. Now this ice, even if you tilt it, you keep it in different sides, still the shape of the ice remains the same. But if you take water, if you tilt this container, you can see the water will move. It will move and become a different, it will come to a different point. So, this is water. If you tilt the container, you can see the water coming like this or in the other angle. So, there water can move to a certain extent, but the same water has the same volume. Now, if you want to pour this into a smaller container, you might not be able to pour all the water into the same container. That is because water has particles somewhat randomly arranged. Unlike the ice, the solid, water, the particles are randomly arranged. Then we have the gases. Now we saw the spreading of bromine gas. From the first gas jar, it spread into the second gas jar. So, the gases are able to move freely. That is because of their arrangement. They are arranged far apart. So, there is lot of space between the particles. They can easily move around. So, that is the basic arrangement of solid, liquids and gases. So, now we will understand their properties. So students, if we look at the arrangement of particles in solids, you can see in as vertical rows and horizontal columns like that, you can see they are very orderly arranged. So we can say in solids, particles are orderly arranged. So here I can say particles are orderly arranged. So if you compare the liquid with the solid, what can you see? The liquid, the particles are not arranged in an orderly manner. So here there is a little bit of disorganized arrangement or somewhat random arrangement. So that is what we need to consider in liquids. So here we can say particles are not orderly arranged. So if you compare the two, you can see there is a very organized arrangement of particles here, whereas in liquids, the organized arrangement is less. There is a certain amount of organization, but still they are somewhat randomly arranged. So we can say particles are not orderly arranged, or we can say particles are somewhat randomly arranged. So what can you say about the gases? There you can see the particles are far apart and they are totally arranged in a random manner. They are not organized at all. So particles are not orderly arranged, or you can say particles are randomly arranged. So here we can say particles are not orderly arranged, or you can say particles are randomly arranged. So that is what you can see between the three states. In the solid state, particles are orderly arranged. In the liquid state, particles are not orderly arranged or somewhat randomly arranged. But in gases, the particles are randomly arranged. So that is the first property that you all need to observe, students. So then we will move on to the next property. So we will move on to the second property where we try to understand the bonding nature between the particles. If you take the solids like I explained to you all, they are very arranged in an organized manner. So because of that, there is a strong bond between the particles. So we can say the particles are strongly bonded in solids. So that is the second property. Particles are strongly bonded. Or in other words, you can say there is a strong bond between the particles of solid. So what can you say for liquids? The particles are somewhat randomly arranged. They are slightly far apart when you compare to the solids. So they are still close to each other, but still there is a bond, but compared to the solids, the bond is not that strong. So the bond between the liquid particles is somewhat weaker than the bond present between solid particles. That is the other property. So we can say, although the particles are close to each other, to one another, close to one another, the bond between particles is comparatively weaker than in solids. So that is the difference between solids and liquids. What about the gases? They were completely randomly arranged. So the particles were far apart from each other. So that means the bond between particles is very, very weak. So here we can say the particles are very weakly bonded. So that is the bonding between particles, because in solids they are organizedly arranged or arranged in an organized manner. The bond is very strong. In liquids there is a somewhat randomness, so the bond is somewhat weaker. But in gases the particles are randomly arranged completely, so because of that the bond is very weak. So then we will look at the third property. So the next property. Now in the solid you can see the particles were closely packed. They are organized and arranged properly. So there is only a very small amount of space. So because of that, now if you take this particle, it cannot move freely with respect to the other particles. Now with respect, let's say we have a particle here. Now it is surrounded by, here you can see students, if we consider this particular particle, it's surrounded by all the other particles there. Now relative to these particles, this particular particle cannot move from its position. So they cannot move from their position, but because there is space between the particles, a very small space, they can vibrate. Vibrate means it can come closer to this particle, then go away, come closer to this one. Like that, it can vibrate. From its position, it can vibrate a little bit. That's possible in solids. So here we can say the particles, I'll rewrite, the particles cannot move freely with respect to the other particles. But they can vibrate from their position. They can vibrate from their position. But you all can imagine, students, between the liquids, the particles were somewhat randomly arranged and there was space. So they can move a little bit more freely compared to the solids. So the particles can move randomly to a certain extent. So there we can say particles can move relative to one another. to a certain extent. So they can move to a certain extent. But in the gaseous state, you all know the particles were very far apart. They are randomly arranged. They are not organized. And there was lot of space between the particles. So therefore, they can move freely and randomly. So here we can say particles can move freely and randomly. So that is the third feature of all these states. So because of all these, you saw that in the solids the particles are organized in a proper manner. So because of that they were very close to each other. So there is very less space between the particles of the solid. So here we can say there is less space. You cannot say there is no space, because you all know, students, when it comes to discontinuous nature of matter, there should be space between particles. But here the space is less. So there is less space between particles, between the particles. Same thing goes for liquids. Even though they are somewhat randomly arranged, there is less space between the particles of liquid. So here also we can say there is less space between particles. So what about the gases? There was lot of space between the gas particles. Why? They were randomly organized. The weak bond was very, very weak and they were able to move around freely. So because of that, there is very much space between the particles. So here we can say there is much space between the particles. So those are the properties. Those are the properties of the three states of matter. We will again go back and quickly go through the properties. So from the diagram, students, if you all are asked to draw and show the organization of particles in a solid, liquid or a gas, this is what you need to show. In a solid, all the particles have to be orderly arranged. In a liquid, they are somewhat randomly arranged or not orderly arranged. But in the gaseous state, they are completely randomly arranged. Because of that, the bonding between the particles is very strong in solids. It's somewhat less in liquids and it's very much less in gases. So due to that, the solid particles of a solid matter cannot move with respect to one another, but they can only vibrate. Whereas particles of the liquid, they can move to a certain extent. In gases, they can move very freely and randomly within the gas or within the space. And also, if you look at the space present between particles, here there is very less space. In liquids, there is a certain amount of space between the particles, but in gases, there is very much space between the particles of the matter. So that is the structure, and that is why they have their different physical properties. So I started by explaining the ice, water and steam. So you all know ice has a certain shape. You have seen the ice cubes of different shapes. Maybe they are cubes or different shapes, but still they have a fixed shape and also they have a fixed volume. Why? Because they cannot move around. The space between the particle is fixed. The particles are organized in a proper manner. They are arranged in an organized manner. They cannot move freely. So because of that, they have a definite shape and a definite volume. But in liquids, you all can see there is a small amount of bonding. So because of that, the particles are somewhat far apart, but they cannot move freely completely. So because of that, they will have a definite volume, but they will not have a definite shape. Whereas if you take the gases, they don't have a definite volume, they don't have a definite shape. You can remember from the joss sticks, the grey color, the fumes, they spread throughout air. Now even the nitrogen dioxide gas, since we had the gas jar, the second jar on top, the nitrogen dioxide from the first jar went into the second jar. It just spreads into the second jar. But if we take off the second jar, you will obviously see the brown color gas spreading throughout air. So that means gases do not have any fixed shape or they don't have a fixed volume. They just take up the volume of the container. That is because they are so randomly arranged. There's lot of space between them. Very less interaction or the bond between the particles is very less. So that is how we can relate the physical properties of the three states of matter to the arrangement of particles. So that is what I am going to do next. So the reasons for the variety of physical properties of solid, liquid and gaseous matter is the diversity of their arrangement. So here students, in this table we have the different properties and we have the solid, liquid and gas, the three physical states of matter. We will try to understand how the property changes with their particle arrangement. So if we take the shape, now as I told you all before, ice has a certain shape, a fixed shape. So if you take a piece of block, if you take a table, if you take a solid fruit or even a marble, a ball, all these are solid substances. They have a definite shape. Their shape does not change. Even ice, only when it melts, the shape changes, but as ice, it has a fixed shape. So all the solids have a definite shape. So when we discuss shape, we can say solids have a definite shape. So how about the liquid? Now let's try to understand this. Now if you had ice, it would have a fixed shape. So it's a definite shape. This is ice. Now if you have water, let's say you take water into a container like this, then it will have the shape. You have seen water taken in beakers or glasses, it will have this shape. Let's say we transfer this water into a conical flask like this. The same water, but here you can see the shape changes. So here you can see if you take it into a container like this, again it will take up that shape. So liquids, here it's water, liquids take the shape of the container they occupy. So they do not have a definite shape. So what happens to gases? Gases again occupy the shape of the full container. If you take gas into an open container like this, it will spread throughout the container. And from the container also, it will spread out into the air. So gases do not have a definite shape. So here we can say, so here no definite shape takes the shape of the part of the container it occupies. What does that mean? Takes the shape of the part of the container it occupies. So, as I explained to you all before, students, here you can see, now this part, now this is the full container, but it occupies only this space. So, the shape of that. Here you can see, like a conical flask, the shape of only this part. Here it is the shape of only this part. So, that is the meaning of having no definite shape, but it takes up the shape of the part of the container that it occupies. But if you take a gas, now if you had a container like that, this is for liquids, the gas will spread throughout the container. Or if it is a container like that, the gas particles will spread throughout this container. You can remember the gas jars from one jar to the other. So here it will fill up the space of the container that it occupies. So that is what you have to write here. So here also no definite shape it takes the shape of the container it occupies. So that is how the gases act. What is the reason? The particles are randomly arranged. There is very much space between the particles. They can move randomly and freely. So because of that, they spread throughout the volume of the container and they take up the shape of the container. But here in liquids, they cannot move freely and randomly like the gases, but they can move to a certain extent. So because of that, they take the shape of the container and the part of the container that they occupy. So that is what happens in liquids. Then if we look at the next property is volume. So here again I have explained this to you all, because the particles are orderly arranged, they are tightly packed, they don't have much space between them, they have space but very less space, and they are strongly bonded and they cannot move around freely. They can only vibrate. So because of that, they have a fixed volume, or we can say they have a definite volume. Then what about the liquids? Now here let's say if this is a 50 milliliter liquid. Now 50 milliliter liquid can be transferred into another container. The shape will change, but still it will only be 50 milliliter liquid or water. If this is 50 milliliter, this is also 50 milliliter, this is also 50 milliliter. Just because the shape changes, the volume will not change. So you can think of this, students. If you have a water bottle, your water bottle, if it is 1 liter bottle, if it is a 1 liter bottle, and you have water up to the mouth of the bottle, can you pour all that water into another water bottle that has a volume of only 750 milliliters? Can you transfer all this water into that? No. You can only fill up to a certain extent, but still you will have some water remaining in the first bottle. So that shows the volume of water is fixed, but it can take the shape of the container, that also part of the container that it occupies. So they have again definite volume. What about gases? Now we saw the gas occupies the full container. So if it was a small container, it would have been present within that container. If the container is larger, it will occupy that space. So if you transfer it into another container that is even more larger, there it will take up that space. So it does not have a definite volume. So those are the properties there. Now if you take volume, solid has a definite volume. Has a definite volume. Liquids also have a definite volume. Here it does not have definite volume and it occupies the volume of the container. So that is what happens to gases. So those are two properties, students. There are two more properties that can be related to the particle arrangement. So when you all understand these properties, you're familiar with these already. You all have to relate it to the particulate nature or how the particles are arranged in each physical state. So with that, students, I will move on to the next slide. Again, we continue the properties. Here we discuss two more properties. One is compressibility, the other one is density. Now, what is this compressibility? So, I will explain this first. Here, students, we take a syringe. A small syringe like this with a piston, right? What you can do is you can take some air into it, colored gas like nitrogen dioxide or bromine gas. Or even if you can't take that gas, what you can do is you can just take the syringe and you know there is air inside. So this is air. What will happen if you place your fingertip here, you just close this open part of the syringe and you try to press this piston. If you try to move the piston, what happens? The piston will move. So you can reduce the volume of the air. So when you move the piston, again you will see it like this. But the piston can come up to a certain place. Still the part is closed. So there the air cannot go out, but you can see the volume has decreased. So when pushing this, we apply pressure. So by applying pressure, what have we done? Here you can see the volume of air is more. Here the volume of air is less. So by applying pressure, we have decreased the volume of air. That is known as compressibility. Now, can you do this with solids? As I told you, we have a wooden block. Can you compress that block? Even if you stand on the block, the volume will not decrease. If you hammer it with something, it will break, but the volume will not decrease. So that means solids cannot be compressed. They cannot be compressed at all. So what happens to liquids? What do you think? Can you compress the liquids? Now instead of gas, if you took water into this, can you close the open end of the syringe and can you push the piston? No. If you push hard, somehow the water will come out. So that means you cannot compress liquids easily. That is also not possible. But here with the example we have understood that you can compress gases. So solids and liquids cannot be compressed easily, but gases, they can be compressed easily. Then we have another property, density. So before I explain that, I will write the properties for compressibility. So here solid cannot be compressed easily. Whereas liquids also cannot be compressed easily. Whereas gases can be compressed easily. So that is the compressibility or ability to get compressed. Solids and liquid, you cannot compress them easily. But gases can be compressed easily. That is why you get the LP gas cylinders. Inside the LP gas cylinder, you all know there is gas, but it has been compressed. Liquid petroleum gas. So that is possible because the gases are compressible. And you have even seen these oxygen cylinders. When people go for diving or it's used in the hospitals, inside that there is oxygen but in the compressed manner. So all those are possible because we can compress gas. So then, if we try to understand density. Now think of these students. So from that activity, when you all weigh the mass of the balloon with air, what do you all confirm? You confirm that air has a mass. So from that we confirm that air is matter. Matter are things that have a mass and they occupy space. So a similar thing. Now you had a balloon with air. So you had balloon with air. You got the weight of the balloon or the mass of the balloon was measured. Now the same balloon, if you fill it with water, the same thing, same size, same shape, everything same, but you fill it with water. And if you weigh, what do you all think? You all play this game sometimes, passing balloons and making sure that it doesn't break. So you have carried balloons with water. What happens there? The mass will be higher. What if you fill this with solid water, that is ice? If it is completely filled with ice and you weigh the mass, what do you think will happen? The same volume, same balloon, the same shape, everything is same, but the substance inside it's different. Air, water and let's say some solid substance. Obviously, you know the solid substance weighs more. The mass will be more. So here we have the same volume, same shape and everything, but when you weigh the mass of a gas, liquid and solid, you can understand solids have a higher mass, water has or liquid has less mass and air has even less mass. That property, the relationship between the mass and volume of substances is what we discuss as density. So if we consider the density of solids is high, density of liquids is also considered as high compared to gases, but density of gases is less. So that is the last property. Again, that is also related to the particulate arrangement. What is it? Now, if you take air, the particles are very randomly arranged. So only a few particles occupy this space. So they weigh less. The density is less. You have heard about the term dense being used. Dense means closely packed, a lot of things together. So here you can see the particles are less dense. But if you take water, you will know that there will be more particles. Although they are randomly arranged, there will be more particles compared to air. So here they are more dense. The same way if you take a solid, again the same balloon filled with solid particles, here they will be very closely packed. So the solid particles are densely arranged. So therefore their density is also higher. So in a solid, the density is high. Compared to gases, water or liquids and solids have high density. So that is what you need to understand here. So when we say density, solids have high density. Liquids also have high density, whereas gases have relatively low density, or we can say less density. So those are the properties. We started by discussing how the particles are arranged in solids, liquids and gases. I am sure you all understood well. And after that, we have related the 4 properties: shape, volume, compressibility and density of these different substances to their particle arrangement. That is what you need to understand well. So, since due to their particulate arrangement, the 3 states of matter have different properties. So, some have definite shape, solids have definite shape, liquid doesn't have a definite shape, gases doesn't have a definite shape. So, because of that, components or substances that we use in our day-to-day life, that we find in our environment, they also exist in the solid, liquid and gaseous state. So, because of these physical properties, they have different uses. That is what we are going to discuss next. So, with that, I will move on to the next slide. So, here again we look at the properties. Shape. So, I told you all a solid has a definite shape because the particles forming it are organized in a regular pattern and are strongly bonded. So, the 2 reasons. The particles are arranged in a regular pattern and they are strongly bonded. But liquids and gases lack a definite shape because their particles are not arranged orderly. So, the particles are somewhat randomly arranged in liquids and they are very randomly arranged in gases, and also they can undergo random movement. They can move freely and randomly. So, because of that, liquids and gases do not have a definite shape. Then if we take the volume. So, already we looked at the shape. So, we look at the volume. Solids and liquids have a definite volume, but gases do not have a definite volume. That also we have discussed. This is because the gas particles spread freely and occupy the entire volume of the container, as the binding forces among gaseous particles are very big. So, here again 2 reasons. They can spread freely and because the binding forces are very weak. So, because of that, they do not have a definite volume. But in gas, solids and liquids, the binding force is somewhat strong and the particles cannot move as freely as in gases. So, because of that, even in the liquid, the particles can move but they can't leave their space. So, they have to have a definite volume. They can move around within that volume. That is why when you tilt the container, the shape changes. Or when you pour the liquid into a different shaped container, the shape changes. But the volume remains the same. Then if we look at the compression, compression means the decrease in volume of matter by increasing pressure. I explained this to you all with the syringe how you can compress gases. solid and liquid matter cannot be compressed easily. However, gaseous matter can be compressed easily. So, this is like a summary of what we already discussed in the table. So, I am sure students, now you all have a good understanding of these properties and you are able to relate them to the particulate arrangement of the three states of matter. With that, I will move on to the next slide. So, here we have an activity to compare the compressibility of liquids and gases. So, this is an activity similar to what I told you. So, these are the materials that we need. We need a syringe with piston. So, here also we need 2 of them. So, we need 2 syringes because we need to test the compressibility of liquids and gases. So, as liquid we will take water, and as a gas, again a colored gas. So, we can use nitrogen dioxide gas. Or as I told you all, we can use bromine gas. That is also possible. So, these are both brown color. They are both brown colored gases, or we can say reddish brown colored gases. So, a very simple activity. You can fill water into the syringe, and while holding the open end, this is the open end. This is the open end of the syringe. While holding that open end, if you try to push the piston, can you all do it? That is what compressibility is. I have already told you all know this. You cannot push it. When they give you the injection, that is what happens. When the piston is pushed, the medicine inside enters into our body. So, that is how the injection is used. But at the same time, if you take a gas, you close the open end of the syringe, you try to push it, you can compress it. That is what we are going to observe now. So, we will go through the method again. The method: draw water into one syringe until half of it is filled with water. The first step. Take an equal volume of nitrogen dioxide gas to the other syringe. So, here also we will use nitrogen dioxide gas. In both syringes, close the open end and push the piston forward. So, in both you can close the open end and push the piston forward. In both cases, compare the ability to move the piston forward. So, that is what you need to understand. When we say compressibility, this is what we need to observe. Compare the ability to move the piston forward. So, you all can understand the steps, students. It's a very simple activity. Let's go to the lab and carry out the activity now. Okay, students. Now we are going to compare the compressibility of a liquid with a gas. So, for a liquid I have water, but I have added color to that so that it will be more clear for you all to observe what happens. And here we have the brown color nitrogen dioxide as the gas. And to do this activity I have 2 syringes, and you all know what compressibility is. When we apply pressure to a certain substance, if we can reduce the volume, that is known as compressibility. We will try to compare the compressibility of liquid, that is water, and gas, nitrogen dioxide gas. So, first I will use the syringe. What I will do is, I will take water, the colored water. We will draw the water into the syringe. So, here you can see as I pull the piston up, the water gets drawn into the syringe. Then I need to place my finger closing this tightly, and if I try to push the piston, it does not move. That means I cannot compress water that easily. I am applying pressure, I am trying to push it, but it doesn't move. But you all know, if we just push it like this, the water will come out. That is, if there is an opening, we can transfer the liquid, but we cannot compress it like this. So by applying pressure, it's difficult to reduce the volume of water. That is, by applying pressure, it is difficult to reduce the volume of liquids. So that is the first part of the activity. Then what we do is, we have the nitrogen dioxide gas here. As you all know, it's brown in color. So again, I am going to draw the nitrogen gas into the syringe. So here students, you all can see the color of nitrogen dioxide gas, the brown color. Now I will have to hold my finger here. I will try to compress this. Can you all see? The piston is moving, and to a certain extent I can move the piston. Up to here I can. But thereafter, I cannot move the piston. It comes back. And also, you all can see a slight difference in the color. When the nitrogen dioxide gas gets compressed, it becomes slightly darker. But when I release it, that is decrease the pressure, volume increases, you can see the color becoming lighter. When I push it and decrease the volume, you can see there is increase in pressure. I can feel the pressure on my fingertip, and you can observe the slight increase in color. So compared to water, we can compress nitrogen dioxide gas. So that means compared to liquids, we can compress gases more easily. So gases are more easily compressible, whereas liquids are difficult to compress. So that is how we compare the compressibility of gases and liquids. Okay students, so you all saw what happened. When we took water into a syringe, I could not push the piston. But when I took nitrogen dioxide gas into the syringe, I was able to push the piston, and you saw the volume decreasing because the nitrogen dioxide was brown in color. And also you were able to observe that the color became a bit darker. Why? Because the particles of nitrogen dioxide came closer to each other. They became more densely arranged. So because of that, the color increased. So those are the observations that you got. So we will write the observations. So here we can say the piston of the syringe with water cannot be pushed forward. But you can say the piston of the syringe with colored gas, or you can say nitrogen dioxide gas, can be pushed forward. So from that, what can we conclude? Water is a liquid. Water could not be compressed. So liquids cannot be compressed easily. But whereas nitrogen dioxide gas is a gas, and it can be compressed easily because we were able to decrease the volume of nitrogen dioxide gas by pushing the piston. So here from this we can conclude and say liquids cannot be compressed easily. Gases can be compressed easily. So that is the conclusion that we can get from this activity. So if I go back and read the observation for you all students, the piston of the syringe with water cannot be pushed forward, and the piston of the syringe with the colored gas, that is the nitrogen dioxide gas, it can be pushed forward easily. And also you were able to observe the volume decreasing and the color becoming a little bit more intense. So from that we can conclude and say liquids cannot be compressed easily, but gases can be compressed easily. So that is the compressibility of substances. I am sure you all can understand that now. With that students, I will move on to the next slide. So water is a liquid as the particles of a liquid are closely packed. So we discussed that before students. When you look at the arrangement, the particles are randomly arranged in a liquid, but still they are closely packed compared to a gas. So here if you take the gas, they are very randomly arranged. So that is what is given to you there. As the particles of a liquid are closely packed, they cannot be brought closer. So you cannot push them closer than this. They need to have that space between them. So because of that, even if you apply a force, you cannot bring them closer. So you can see as the particles of a liquid are closely packed, they cannot be brought closer by applying a force. So you cannot compress liquids. Therefore, liquids are relatively difficult to compress. But if you take a gas, in a gas there are wider spaces among the particles. Therefore, by applying a force, the particles come closer. So when you push, these particles can come closer, only up to a certain extent. So that is why the gases can be compressed easily. So as examples, I told you all the LP gas cylinders. In that gas, the LP gas is compressed into the cylinder. Then you know about oxygen gas cylinders. Oxygen cylinders or oxygen gas cylinders that is used in hospitals, divers, mountain climbers. So in all these, inside the cylinder, the gas is stored in a compressed manner. So that is an example for compressibility of gases. Gases can be easily compressed. So I am sure you can understand that, students. With that, I will move on to the next slide. When comparing the densities of solids, liquids and gases, it is seen that solid and liquid matter have a high density, but gases have a low density. Again related to their particle arrangement. If we take a solid, a liquid and a gas, so you have seen, students, in a solid, the particles are arranged in an organized manner or orderly arranged. So because they are orderly arranged, you can accommodate more particles into a certain space, a fixed space. Whereas in liquids, they are somewhat randomly arranged. So you can accommodate less number of particles there. So here in gases, they are very randomly arranged. So in a solid, liquid and gases, because of their arrangement, you have more particles here. I have not filled the full space, but still you can see compared to liquids and gases, there are more particles in this space. Same time, liquid has less particles, gases have even less particles. So I explained with the balloon, weighing the balloon inflated with air, a balloon filled with water, a balloon filled with the same amount of solid. So that is possible, and the difference in mass is caused because of this arrangement. When there are more particles, obviously the mass will be more. And we can say the particles are more dense. So that means solids have a higher density. Whereas if you take the liquids, again compared to gases, they also have more particles inside. So because of that, they also have a higher density compared to gases. Whereas in gases, the particles are randomly arranged, more space among them, less number of particles within an area. So therefore, within this particular volume you can take. So because of that, the density will be less. Now you don't have to worry about this density in detail. You will learn density, you will learn about this concept in your higher grades. So for now, just understand solids and liquids have higher density compared to gases. So when comparing the densities of solids, liquids and gases, it is seen that solid and liquid matter have a high density, but gases have a low density. That is what you need to understand, students. So with that, I will move on to the next slide. Here we look at some uses of solids, liquids and gases. Solids, liquids and gases are used for various purposes depending on their properties. Some examples for their instances in which they are used are given below. So under that we will look at the examples of solids where they are used in day-to-day life. So if you look at these diagrams, you can identify what they are. The first example, parts of machinery. So here you can see there is a sewing machine. So sewing machine or any type of machine, right? Sewing machine. In this sewing machine, there are so many different parts. That also has different properties. You can see a plastic cover there. Then you can see a metal, the needle and the sewing part of the machine is metal. Inside also there is a machine that is working. That is again made up of metals. That has different properties from the covering. But all of them are solid components. So because they are solid components, they can be made into this particular shape. They are very strong. They can be used for sewing. So all that is possible because of the nature of the solid and its physical properties. The same way, if you look at this car, so you can see the parts of the car. Again here the body of the car, the door, usually they are all metals. If you take the tires, they are made up of rubber. Then again wheel cups, they are made up of metals. Then here you can see the windows, all are made up of glasses. Even the mirrors, again glass. Again those are all different types of solids and they all have different properties. But the basic properties of solids, of having a definite shape, definite volume, all that is there. They cannot be compressed easily. So because of that, the solids can be used as vehicle parts. So many different parts of the vehicle is made from solids. But you all know inside the tire there is air. So that is also used in vehicles, but most parts are solid. Then we have all these examples. The building materials. So when we say building materials, there is cement that we use, the bricks, then you use steel rods or steel wires, all steel is used, then there is glass that is used, then there are different types of wood or even different sheets like asbestos sheets and things like that. Then we have soil, wood and all these plastic parts. So if we say building materials, you all know in a household or a building, so many different materials are used. So here all different materials, not all but many different materials are shown to you. So these again have the basic properties of solids. They have a definite shape, definite volume, they cannot be compressed and they have high density. So because of that, we can use them to make buildings. So uses of solids. Then weapons. You know about different weapons used for different purposes, especially for defense purposes during wartime. Different countries use weapons. So they are also made up of solid. Again, because of their properties. They are more stronger, high density, they cannot be compressed, and definite shape and definite volume. So that is how you have to use the uses of these materials or solid substances in our day-to-day life. So I am sure you all can think of many more examples, students. You all use so many things. You all use your water bottle, the school bag, your pencil case, your pencil pouch or purse, even your dresses. All those are different solid materials. So they have their own uses. Because they are solids, they are useful, as well as because of their specific properties also, we use them for different purposes. That is what you need to understand. So with that, students, I will move on to the next slide. So again, solid, liquids and gases are used for various purposes depending on their properties. Some examples for the instances in which they are used are given below. So this is for liquids. Here we are going to look at liquids. If we look at the liquids, here you can see we have a mercury thermometer. Mercury thermometer. When we say mercury thermometer, you all know, students, the outer side is made up of glass. This bulb also is made up of glass. But inside, what you see here, that is mercury. That is the one that expands and it rises up along this thin tube so that you can read the temperature of a person. The body temperature of a person. So that is a liquid. This mercury is a liquid. It is a liquid. So although the rest of the parts of the thermometer are solids, mercury is a liquid. So use of mercury in thermometers. Then here we have the hydraulic jack. The second one, this is a hydraulic jack. So hydraulic means a liquid. You know the use of a jack to raise the vehicle so that you can change the tire in case of the tire becoming flat or something. So you use the hydraulic jack. So hydraulic jack uses a liquid. Jack uses the liquid. That's why the name hydraulic, related to a liquid. Then we use water as a medium of transport or liquid as a medium of transport. Here what I have shown are two instances. You can see sometimes they use water rivers to transport logs. So transport of logs through river of logs along the river. So with the river water flowing, the logs also flow. So you can easily transport it from one place to the other. Same way, the ships sail in water, boats sail in water. We use water, ocean, sea, all these as medium of transport. So here also it is a medium for transport. Is this the only medium of transport? Are these the only examples for liquids being used as medium of transport? You have learned another example. You have learnt about transport in plants. Can you all remember that, students? The roots of plants absorb water and mineral, and this water and mineral is transported through the plant through a tissue called xylem. You all don't have to worry about the name of the tissue now, but that is transported. So because water goes through the stem of the plant, the minerals and vitamins are also transported. So there again water acts as a medium for transport. So transport of minerals with water in in plants. A similar thing happens in our body also. What is that? Our blood. Blood transports nutrients, it transports vitamins, minerals, digested food, all that is transported by blood in our body. This blood also has water in it. It's a liquid. So there again, it acts as the medium for transport. So that is also something you need to remember, but you don't have to go into detail, students. Just remember that blood is also a medium of transport. So blood is also a liquid. It does have solid components in it, but it is a liquid. It acts as a medium of transport. This is something familiar to you, but you have learned this in the plants lesson. So with water only, minerals are transported throughout the plant. So these are some examples for the uses of liquids in day-to-day life. Mercury thermometer, hydraulic jack, and as a medium of transport. Like this, we will look at the uses of gases as well. So here we have solids, liquids and gases are used for various purposes depending on their properties. Some examples for the instances in which they are used are given below. So here students, we are going to consider the gases, the third physical state of matter. So when we say gases, you can look at all these pictures. You are familiar with all these instances mostly. The first one, inflating tires. So when you use the pump, the cycle pump, you pass or you inflate the tire with air. So there inside the tire, there is air. That is in the gaseous state. So that is possible. Now you have seen when it's deflated or when there is a puncture in the tire, it becomes very soft. It's not inflated. You can see the shape of the tire. So this air gives the shape and gives the ability for the tire to rotate in that particular manner. Not only in bicycles, even in other vehicles also, there is air inside the tire. So that is one application. Then in pressure cookers. So here we have the pressure cookers. Now you all have seen pressure cookers, or you all know that you all use pressure cookers at home. Maybe you all don't cook, but your elders cook at home. So you would have seen when we use a pressure cooker, you would have seen this gas coming out. You would have heard the whistling sound of the pressure cooker. So there is high pressure generated within that vessel. That is possible again because of the gaseous state substances. So there it facilitates the cooking. Usually cooking with a pressure cooker is somewhat faster than cooking with a normal open vessel. So that is facilitated again by gases. So that's the pressure cooker. Then we have the hydrogen balloons. I am sure you would have loved playing with hydrogen balloons. You would have seen the decor with hydrogen balloons. What's the difference? Normal balloons, when you blow them, inflate them, when you put them out, they go up, but still they come down and fall down on the floor. But hydrogen balloons always tend to go up because it's very lighter. So then we tie the ribbon like this with colored ribbons. We make different decor. So all that is possible because of the hydrogen gas. This hydrogen is a gas. So we have the hydrogen balloon. Hydrogen balloons. Then we have the last one. In liquid petroleum gas, I mentioned this before also students, LP gas, liquid petroleum gas cylinders. Now in these gas cylinders also there is gas. So that is why we say gas cylinders. Inside the cylinder, the gas, that is the liquid petroleum gas, is compressed and it's filled into the cylinder. You use this in your household, so you are familiar with this concept. So these are some of the uses of different gases. Inflating tires, pressure cookers, then hydrogen balloons and LP gas cylinders. So these are different uses of gases. So that is again related to the physical property and particulate nature of gases. So in all these, you can see students, when you fill up the air into the tire, it occupies the full volume and it takes up the shape of the container. Same goes for the cylinder, and there also, even in the balloon, as you keep on inflating the balloon, the volume can increase and the shape will change. So there air takes up the shape of the container as well as occupies the full space. Here you can see the compressibility of gases. So in all these instances, these uses are possible because of their particle arrangement as well as their physical properties related to the particle arrangement. So with that, students, I am sure you all have a very good understanding and idea about how particles are arranged in the three states: solids, liquids and gases, and how they give rise to the different physical properties. So with that understanding, I will move on to the next slide, where we have an assignment. Make models to demonstrate the particulate nature, that is discontinuity of the three states of matter. So this, of course, students, is something that we have been discussing so far. We did a few activities. I explained some of the examples for particulate nature of different solids, liquids and gases. You can use those ideas and make models. So if you can remember, students, when we said solids, we use the chalk, the colored ink being absorbed through the chalk particles. That was one example that we used in the lab. That was the activity. Similar to that, for solids, you can even take two different solids. Say, as I told you, the colored powder. So into these two containers, you all are familiar with these rangoli powders. Normally the powder they use to draw designs on the floor. During weddings or to make it nice, they have used that. Then I told you all, during the festival, you can use these colored powder. So what you can do is, you can take white color powder, and maybe red powder or different colors. And then you can put them into one container and you can try to mix them. Or you can take a piece of white chalk. You can take white chalk and you can take a red chalk. We have used chalks for activities. You all know these are available in the lab. You can put both the chalks into a mortar and pestle and then you can grind them together. So when you grind them together, what happens? Particles of the white chalk mixes with the red chalk. How is that possible? These are solids, but still they are made up of particles. That's why you are able to grind them and they get mixed. The white color particles mix with the red color particles. So that is a concept that you can use to make a model. Then if you consider the liquids, like we did before, for liquids also, you can use colored liquids. Colored liquids. Colored liquids means you can use ink or food coloring. You can also use food coloring. Then you can use water paints. Any of those can be used. So you can take these colorings, you can put it into water, but you can do it in an innovative manner so that you can demonstrate the discontinuous nature. At the same time, you can make it interesting. That's why they mean by making a model. Then for gases again, we have looked at colored gases. Colored gases. So when we say gases, colored gases can be used, or fragrance in gases like perfumes, joss sticks, or air fresheners. So all of them have fragrance. So spreading of the fragrance can be demonstrated. The color, by the spreading of the color, you can demonstrate the discontinuous nature. Again, these can be made in very interesting ways. So this is an assignment that you all have to do. Make models to demonstrate the particulate nature or discontinuity of the three states of matter. I have just given ideas only. I am sure you all are very innovative. So you have very good ideas and you all have very innovative skills. So I am sure you all can come up with very creative ideas and make models to demonstrate the particulate nature, as well as you can make the model very interesting. So with that, students, I have come to the end of this chapter. In this chapter, we discuss the three physical states of matter, and in those three states, solids, liquids and gases, how particles are arranged in them, and because of this arrangement, the properties of these three states of matter. So I am sure you all have a very good understanding of this concept.